As a young citizen of India, armed with technology, knowledge, and love for my nation, with a vision of transforming India into a developed nation, I am joining Shobhit University. What about you?
Very good morning to all the participants from India and abroad. Shobhit Institute of Engineering and Technology, Meerut, deemed to be university, and Center for Agricultural Informatics and E-Governance Research Studies, and Center for Agribusiness and Disaster Management Studies, Extent. Greetings to all the participants from India and abroad who are attending today's national webinar series on doubling farmers' income by 2022, Atmanirbhar Bharat in agriculture. This webinar series is being hosted on every Thursday at 11 a.m. to 1 p.m. Indian Standard Time. Today, 11th February 2021. This webinar is on the topic Actosol, organic humic solutions for increasing crop yields and quality while increasing farm income and improving soil health. Let me repeat once again. Actosol, organic humic solutions for increasing crop yields and quality while increasing farm income and improving soil health. On behalf of the Honorable Chancellor, Honorable Vice Chancellor, the faculty members of the university, and on my behalf, and as Professor Emeritus and Chairman of the Center of Excellence, Center for Agriculture Informatics and E-Governance Research Studies, and Center for Agribusiness and Disaster Management Studies, welcome our today's guest speakers, Dr. Dhaman Walia, President and CEO, ARCTECH Incorporated, USA. Mr. Sachdeva, Independent Agriculture Consultant and Innovator Thinker Agriculture Value Chain, Pune, Maharashtra. Mr. Samir. So far, under this webinar series, the university has organized 19 webinars on the topic Role of Agricultural Cooperative Societies and E-Governance, Blockchain Technology-Based Fishery Value Chain, a self-contained village, a felt need of the day, Spices Informatics Network Value Chain, Lantana Camera, a camouflaged treasure trove, Smart Hill Agriculture, Mera Mobile, Mera Marketing, Integrated Mariculture, Aquaponics, and Precision Agriculture, in short, map of biofarms for income revolution, Smart Tribal Agriculture for optimizing value chains, Digital Agri-Tech and Industry Perspective, Land Resources Information Systems in India, present and road ahead, Weather Decision Technologies for increasing farm income, Big Data in Smart Farming, Sustainable Soil and Land Management for Climate Smart Agriculture, Understanding Market Dynamics for increasing farm income, Role of Technologies in managing crop risk, How to generate additional profit via simple, attractive approaches in farm produce, Adoption of Flexi Rubber Check Dam Technology, Adoption of Flexi Rubber Dam Technology, Potential benefits for farmers in rain-fed and coastal agro ecosystems, Realizing the economic benefits of agroforestry. Today is the 20th edition of this national webinar series, which will be addressed by a panel of 2 members consisting of a distinguished agricultural scientist and an agricultural value chain expert on the topic Actosol, organic humic solutions for increasing crop yields and quality while increasing farm income and improving soil health. We should notice the key words: Actosol organic humic solutions, increasing crop yields and quality, increasing farm income, and improving soil health. We'll find as to how to go about it during the address of both Dr. Dhaman Walia and Mr. Samir, Sachdeva. Agriculture sector, the foundation of Indian economy. Agriculture sector is the foundation of the Indian economy. It employs more than 50% of India's workforce and contributes almost 7 to 18% of its GDP. At present, agricultural livelihoods are being severely impacted world over as a result of anthropogenic global warming and climate change. India's labor-intensive and subsistence-based agriculture sector is particularly vulnerable to this development. Climate change has both direct and indirect effects on agriculture productivity, including changing rainfall patterns, severe drought, flooding, and changes in the geographical redistribution of pests and diseases. Indian farming community comprises of about 14 crore farmers, of which 85% of the farmers have small and marginal size operational holding. And for them, so far, there are no agricultural reforms that have taken place except the 3 recently enacted agricultural acts in India. Farmer needs timely, location-specific, and personalized information for effective control on their production, risk, and then market their produce to identified market opportunities. Many national level programs, namely Digital India, Make in India, Skill India, Startup India, and Stand Up India, have faced operational difficulties for its impact at farm level and farmer level, and that too at small and marginal farmers. Steps towards Indian agricultural reforms. I would like to quote the report of doubling farmers' income by 2022, report 2018. In this report, it has recognized digital technology in agriculture is an imperative, is needed, it's urgent. And its volume 12B, it exclusively adopted 4 chapters in which digital technology in agriculture have been detailed very effectively. And it also recommends 7 mission mode programs as a strategic use of digital technology in farming systems life cycle, namely digital agriculture, digital technology and innovation in agriculture for transformational reforms in agriculture sector, smart irrigated agriculture system, smart rainfed agriculture systems, and smart tribal agriculture system. For digital technology in agriculture, the agriculture sector has been considered as a 3 vertical: smart tribal farming, smart rainfed farming, and smart irrigated farming. Second is digitalized agromet advisories and agricultural risk management system. Agricultural risk management solutions. Digitalized agricultural resources information system and micro level planning for achieving smart village and smart farming. In India, we do not have a comprehensive agricultural resources information system at grassroots level. What is available below the ground, what is available on the ground, and what is coming to the ground, we don't have an agricultural resources information system at farm level and farmer level. Fourth is digitalized value chain for about 400 agricultural commodities. Digitalized access to inputs, technology, knowledge, skill, agricultural, finance, credit, marketing, and agribusiness management to farmers. The sixth one is digitalized integrated land and water management system. Per drop, more crop. And last one is digitalized farm health management system, integrating farmer health, plant health, soil health, animal health, water health, and fishery health. Even though the Western countries, they talk about national, one nation, one health, eco health. And during the recent budget in India, 2021-22, the government of India also announced establishment of National Institute for One Health. There are 3 farm acts which were enacted in 2020. Farmer Produce Trade and Commerce, Product Promotion and Facilitation Act, Farmers Empowerment and Protection Agreement on Prices Assurance and Farm Services Act, and Essential Commodities Amendment Act. With these 3 acts and the 7 mission mode project, digital technology and agriculture can facilitate at least one agri-tech startup in every Gram Panchayat. It means that there is a possibility of establishing 2.25 lakhs agri-tech startup at grassroots level, at Gram Panchayat level, to help to facilitate 14 crore farming community in the country, out of which 85% are small and marginal farmers. The second step is Atmanirbhar Bharat. What is the road ahead? Atmanirbhar Bharat is the vision of the Prime Minister of India, Shri Narendra Modi, of making India a self-reliant nation rested on 5 I's: intent, innovation, investment, infrastructure, and innovation based on 5 pillars: economy, infrastructure, system, vibrant demography, and demand, whereby the strength of our demand and supply chain should be utilized to full capacity. This was announced on 15th May 2020 by the central government. Atmanirbhar Bharat in agriculture. During this third tranche of Atmanirbhar Abhiyan, agriculture sector has got a boost of about 1.5 lakh crore investment. Now let us come to the topic of today: sustainable soil use and management. On every year, on 5th December is celebrated as World Soil Day. In this year, in last December, 5th December 2020, the theme was Keep Soil Alive, Protect Soil Biodiversity. Soil alone, protecting soil biodiversity, it means 8 sustainable development goals. Goal number 1, goal number 2, goal number 3, goal number 4, goal number 7, goal number 12, goal number 13, and goal number 15. Healthy soil and healthy seeds will lead to nutritious food. The Modi's government is setting up a soil health lab throughout the country to enable their easy access to farmer. It has sanctioned 429 static labs and 102 new mobile labs and 8,752 mini labs, 1,562 village level laboratories to improve productivity of Indian farms. More than 16 crore soil health card database in the country, and integrated soil fertility management is being promoted. Soil is a very complex and often undervalued element, teeming with life. Soil is one of the essential components of land. Topsoil is the layer closest to the surface, and it contains the highest amount of organic carbon, and given this, it is the most productive layer. 1 centimeter topsoil can take from a few hundred to thousands of years to form. Given this, it is considered a non-renewable resource. Deeper layers in the crust can contain other natural resources, including groundwater, mineral, and fossil fuels. Given this, many global policy frameworks, including the United Nations Sustainable Development Goals, directly and indirectly address land and soil. Land governance is complex, but we will benefit from the services that healthy land and soil provide, be it nutritious food or clean water or protection against diseases or construction of materials. When we look at farmland, forest farmland or versus plain farmland, we see the different characteristic. When you look at farmland in forest, it is a healthy soil. But in farmland in plain area, it is an average soil. In forest, we have a more humus content. In plain area, it is average humus content. In forest area, less nutrient deficiency. In plain area, average nutrients. And in forest area, natural fertilizer and chemical free yield. But in plain area, more use of fertilizers and chemicals. And in forest area, even rainfall distribution, but in plain area, not even rainfall distribution. On 31st December 2020, Dr. Nadrajan talked on the topic sustainable soil and land management for climate smart agriculture. After this talk, Dr. Dhaman Walia wrote to me, that watched December 31st, 2020 webinar with Dr. Nadrajan on sustainable soil and land management for climate smart agriculture. I noted in his slide, out of total geographical area of 327 million hectares, about 121 million hectares is affected by erosion, salinity, and alkalinity. Vegetation and biodiversity loss is by 50%. About 55 million hectare lands classified as wastelands. Salinity is a serious problem. Problem in 25 million hectares in irrigated land. Then he asked a question, am I correct that almost 78% of agri land in India is impaired? This shows his concern, even though he lives in US. Reason I'm restating these to get clarity of these numbers as well. Also, I would like you to share with him that use of our Actosol has been proven for erosion control, remediation of eroded lands, and salinity impacted, and increased drought and salinity tolerance. We have farmers in USA and Egypt achieving remediation in 1 to 2 years compared to conventional management practices, which can take 10 years or so. I have attached our white paper on soil health. If you wish, please forward to him, and we would like to see whether we can work with him to take a few of the degraded areas for remediation he highlighted in his presentation. Greatest by Dr. Dhaman Walia, for which Dr. Nadrajan sent a reply to him that you are right in your understanding of the status of soil degradation in India. More than 2/3 of the land resources are in very bad shape, either due to erosion or salinity or vegetative degradation. Happy to note that your Actosol can be effective in remedying the degraded soils much faster and cheaper. Hope you may be having some demo areas in the country to showcase its application, in which the line departments and farmers may be interested before its adoption in their fields. That's how Dr. Nadrajan replied. This has attracted us to invite Dr. Dhaman Walia to address this webinar series today. University envisages to have collaborative projects in this area Dr. Nadrajan will certainly be associated. Dr. Walia also said in his communication to me, I quote, also I noted the Chancellor mentioning about his mango plantation where certain areas were not producing acceptable yield and quality. Please let him know. Most likely, soil in this area was depleted in organic humic matter. Actosol is proven in Egypt for addressing this issue in mangoes cultivation. By the way, they call it Hindi fruit. Hopefully, Actosol can address this at his mango farm. Soil health today is at the crisis stage. Soil health today is at crisis stage. In India, almost 60% of 160 million hectares of agricultural land impaired due to excessive erosion, salinity, and alkalinity. UNFAO reported almost 25 billion tons of topsoil is lost worldwide every year, and India alone is losing 5.3 billion tons every year, according to the synopsis of Dr. Dhaman Walia for this seminar today. UNFAO declared 2015 as the year of soil. Soil organic matter or humus has been recognized by humans through the history of farming as the most important basis of soil health or soil fertility. Humus is a relatively stable component formed by humic substances, including humic acids, fulvic acids, and humans. The humic substance in soil are the fourth largest storehouse of carbon in our planet, after sedimentary rocks, fossil fuels, and oceans, according to the synopsis present, submitted to the webinar by Dr. Walia. He also talks about, biological benefits, chemical benefits, and physical benefits, which you can listen during his talk. According to Dr. Dhaman Walia, both the scientific research and real-world applications are proving that humic substances products derived from humic-rich low-rank coals are beneficial in agriculture applications in US and other countries to restore soil health and improve crop yield. Why not in India? The Doubling Farmers' Income by 2022 report recommended integrated farm health management, plant health, soil health, and etc. Let us now turn to Dr. Dhaman Walia and his Actosol expert, Mr. Sachdeva, for their address. Today's topic will motivate and galvanize the participants watching over the telecast through facebook.com, Shobhit University India, or youtube.com, Shobhit University in, for establishing agri-tech startups in integrated farm health management, at least one in every Gram Panchayat, totaling 2.25 lakhs agri-tech startups. Let me invite Dr. Dhaman Walia, a distinguished agriculture scientist and NRI, to address webinar. Let me introduce him. Mr. Manish, can you display? Mr. Manish, can you display his profile? Mr. Manish?
Sir, I am showing, sir, please.
Okay, fine. Dr. Dhaman Walia is the founder, president, and CEO of ARCTECH Incorporated, USA. He was born on December 29th, 1946 at Naba, state of Punjab, India. He had his BS Chemistry, Physics, Geology from Punjab University, Chandigarh, MS Chemistry, Physics, Geology, Punjab University, MS Mineral Science Geology, Miami University, Oxford, USA, 1972, and PhD Mineral Science Geology, Miami University, Oxford, 1977. He's a research scientist at Illinois Institute of Technology Research Institute from 75 to 78. He was a fossil energy specialist, Oak Ridge National Laboratory from 78 to 81. He was a technical director, Research and Development Division, United Coal Company, Bristol, Virginia from 1981 to 84. He was a manager and director, Environmental Sciences and Technology Group, Atlantic Research Corporation, Alexandria, Virginia from 1984 to 87. He was a founder and president, ARCTECH Incorporated from 1988 to till today. His professional affiliations include American Institute of Chemical Engineers, American Defense, and American Society for Microbiology, American Chemical Society, National Defense Industrial Association. He was also an advisor, Humic Science and Technology Conference from 1997 to date. And he is the recipient of 7 US patents. With this introduction, we welcome Dr. Dhaman Walia, our proud NRI scientist, to address the participants of this national webinar series on doubling farmers' income by 2022. And we welcome Dr. Dhaman Walia, and hope it is very late morning in US, and it's your interest that you are addressing the participants of this national webinar series. We thank you and we welcome you, and we'll invite to address. Over to Dr. Dhaman Walia.
Well, namaste to all of you, and I really appreciate the opportunity to participate in these webinars. You're addressing the issue about the doubling the farmers' income. And so Professor Moni, I've been following up on your work for some time, and quite been impressed with what you're contributing in this field, as well as learning about the Shobhit University. Quite a remarkable that with the vision of your Chancellor, Mr. Vijendra, that it has been established in a rural part of in Uttar Pradesh. My only remembrance of Meerut is that the laddu is coming from there, because I grew up in Punjab area, and so I've now learned a lot about the area where your university is situated, and I've been involved with addressing these issues from a different perspective, because I came into an agriculture field as a geologist, so I understand our Earth's resources, and I understand the soil systems, and I also enter into this field from addressing the solution for energy by utilizing coal, and that has led me to then create a multi-product solution from coal, which addresses then many solution needs which we are currently grappling with, such as climate change, energy, the food, water, and dealing with many of the other issues or health issues. But in this particular webinar, we're going to focus on one of the product we make, which the brand name is Actosol, and it is an organic humic material which is derived from coal. And this has been in use in the market for now almost 15 plus years in USA and China and other countries. But in India, we have introduced its applications in the last 3 to 5 years. Let's see if my screen will come back. So I'm going to share with you in this particular understanding in 3 basic areas. One, what is the current baseline? Because we are now trying to grapple with how to double the farmer's income. And so first thing we need to know is that what is our current baseline income of the farmers, which is an average income. So in this particular graph, I have shown that what are the government statistics or the government of India's reports are showing that the farmers per month income. And I'm sure many of you can relate to these numbers and rupees per month. And on the right extreme is the bar, which is indicating that what is the livable income, which is about 20,000 rupees per month. And I do recognize that many living in metropolitan areas or larger cities, this amount is a relatively small amount, but that is the average number government of India puts out. So the two states, Punjab and Haryana, are the farmers there on an average have a 15,000 rupees per month, which is again below the livable income. But then when you come into these other states, Bihar, Uttar Pradesh, Madhya Pradesh, even going into some of the southern states, the income levels are less than 5,000 rupees per month. So that is the crux of the challenge we have. As Professor Moni shared, that almost 50-60% of the population of India is in the farming enterprise. And they are the ones who are not able to sustain, and many of them are on a subsistence. That means that they are able to grow only enough to feed themselves. And right now, this has become the front and center issue in India with the farm protest going on. So we need to find a way to change this dynamics. Number two, can you move to the next slide, please? In this, what I'm showing here is that what are the average revenues farmers produce on a per acre basis for some of the major crops. And here you can see that some of the major crops which are most commonly are grown are the rice, wheat, and some barley, and in India they call it a jawar. And some of these crops average, they're producing about 50,000 rupees, 60,000 rupees per acre. But the most needed crops are somewhere in the less than 20,000 rupees per acre. So when you take a look into as to the total income farmer can produce is not there, with this kind of revenues they're producing. And this problem is further compounded because the majority of the farmers in India have a very small land holding. My understanding is average land holding is about maybe 2 hectares, which is does not give a large enough land area to be able to grow much larger volume of crop. Compared to in USA, the farmlands can be somewhere between 1,000 acres to 100,000 acres. These are very well mechanized and their crop yields are relatively high. Next slide, please. I'll show you the comparison. Here I'm comparing that what are the crop yields in India versus USA. The crop yields are in green color, and the USA yields are given in a blue color, and you can see the dramatic difference here. So when we start looking at, okay, what can we do to increase the farmer's income, immediately we can make a conclusion that we need to help farmers to increase their crop yields, to a world standard. And so that brings us to the challenge which Professor Moni also alluded to, and I have summarized again. As I did more research on it, I found that 60% of the farmlands in India are no longer healthy. And India has the second largest agricultural land in the world, and about 160 million hectares. After USA has about double of this. But also the half of the land in India is irrigated, which is world's largest. And so the question is, here India has a very large agricultural land, and it's being irrigated both from plentiful of rain, which comes onto the Indian subcontinent. And of course, India has a very large number of rivers, lakes, and also, of course, we have, the Himalayas mountains, which are snow covered, and in the spring and the summer months, they produce a lot of water. So India has a huge amount of water on this continent, and it's being made available to irrigate the fields, but still we have a serious problem going on. And it's because the today almost 90 million hectare, which is about half of the total land, is been degraded because of erosion, salinity, alkalinity. They're deficient in secondary and micronutrients. In fact, Professor or Dr. Nadrajan, in his presentation, he showed a newspaper headline from Karnataka where it says farmers are toiling on the decaying soil. So this is where we have, of course, India going back for thousands of years has been one of the most fertile area, and that's why throughout the history many invaders have come into India because of very productive farmlands and very good climate and other attractive features in India. So today India is facing this big challenge, but this is not only in India. This is a trend which is also happening worldwide, and I'll share some of that with you. So what are the trends and opportunities in agriculture in India? Of course, farmers are seeking increasing yield, increased income, while meeting increased domestic and international demand, because India's population is increasing. And also India is also becoming from an importer to an exporter of food grain. And it's certainly, but farmers are facing increasing phytotoxicity of the plant and using a very expensive plant protection chemicals, and which is leading to an increase in costs. And it's also decrease in the they want to decrease the costly chemical. The public wants a safer products, organics. So there is a increased demand for organic food production. In fact, India in the recent years have implemented a similar to USA, a national organic program. But one of the challenge which is happening in India is that because of the excessive use of these chemicals, that India actually is producing less. For example, from the Indian government's scientist report says that some years ago, India farmers used to produce about 25 kilograms of food grain with every kilogram of fertilizer during the 1960s. But now it's gone down to 8 kilograms per kilogram of fertilizer. So on one side, the fertilizer use is increasing, but on the other side, the crop yields are going down, and it's being attributed to the lack of organic matter in the soil. So the other issues are, of course, the climate change, now increasing droughts, and the salinity is increasing because of excessive use of the groundwater. And as the groundwater is pumped out, it becomes more saline, and then also it makes the soils to be less productive. And of course, another huge issue continues to be on the farms is the farm wastes. and I'm aware of the big issue about this burning of crop residues, which is leading to a huge pollution problems. And I recently heard that the government has now mandated that the farmers cannot burn the crops, but farmers have no other choice. So that is leading to a huge issue on the farmlands. Next slide, please. So, as Professor Moni also mentioned, that this soil degradation is becoming a huge issue worldwide. You know, this is a UN Food Agriculture Organization's report, which saying that about 25 billion tons of topsoil is being lost worldwide, and by 2050 we may be reaching a scenario where our soil simply will not be productive, and so there is a lot of worldwide now talk about this thing, but the solutions still are not being applied in where this trend need to be reversed. So United Nations had declared 2015 as a International Year of Soil. Next slide, please. In fact, one of the very recognized expert in the soil from Ohio State University, NRI Professor Ratan Lal. In fact, he was at the invitation of Government of India at the Parliament a couple of years ago, and he was interviewed by one of the local television channel or government channel, I don't know, but the link is there. And he made a case that we need a new agriculture revolution, which should be soil-centric, not seed-centric. Because as I'm sure you're hearing, there's an increased push for using a genetically modified seeds to increase the crop yield and overcome some of the other issues. But that's leading into other collateral damage and also increasing public concern about their health concern. So the soil is where the answer is, and that's the case what Professor Ratan Lal made. Next slide, please. So let's get to the science. So what is really soil? When we look at soil, it's worldwide. It has essentially same components. It has the mineral matter, it has a water, it has air, and then uniqueness in our soil on our planet that it has a organic matter, which is the smallest component in there. And this, we have generally known this organic matter, we have called it humus. In fact, the word humus is origin is from Romans, from the Greek language. And when I went into Egypt for the first time, I was trying to understand what happened there, that it used to be a very fertile land because of the Nile River. So as I was reflecting on this thing, I came to conclusion that Mark Antony, he did not stay in Egypt, but he did not stay in Egypt for Cleopatra, but he stayed there for the fertile soil of the Nile Delta. As you know, that the Nile River, starting from Lake Victoria in Kenya to, as it moves, it creates a flooding, and it created a very fertile soil. So when Roman armies went to conquer the different places, they of course took their horses, and they took wheat seed with them. So they not only needed to feed themselves, but they needed to feed the horses. So when they reached Nile Delta, they found it to be very, very fertile soil, and that you can seed it, put the seed, and you can harvest in about 30 to 45 days. So that was the reason they stayed in that delta, and that led to a whole new events in Egypt. Now, of course, in India, we've been in agriculture, area for, probably much longer than, Romans and anybody else, for tens of thousands of years. But as I was trying to understand about where the wisdom or the knowledge has come from, I came across this shloka in Ajurveda, number 30. It says, the translation is that, "O Lord, thou art the creator of juices in the soil." And I was quite struck with that, and I showed that to that particular this shloka and the rest of it to one of the expert who knows Sanskrit, and he said that you did not get a complete understanding. It goes on further to say that it connects the non-living to the living. What it really is a remarkable, science. It is explaining us that this humic organic matter, which we call humus, is so important that we still don't know whether it was came before the plant matter or it came after the plant matter. This is one of those chicken and egg situation, but our planet is unique. So far, we have poked around on many other planets, out there in space, but we have found all the similar minerals, elements, but we have not found any place, anything like what we have, this humus, organic matter on our planet. So this really has been a remarkable, unique to this planet, and this is what makes it sustainable. Can you go back to that slide, please? I want to make a point, share with you that, so what is this humus or the soil organic made up of? It's made up of three components. When we look at its soil chemistry, and we can then start developing a understanding. The three components are the humic acid, which is soluble at high pH. The second component is a minor component, is a fulvic acid, and third is a human, which is an insoluble form. And among all of three of them, the humic acid and the fulvic acid, or humic acid, which is the largest component, is the most active form. And there's Professor Davis at Northeastern University, who has done a lot of research on humic substances. He calls that the humic acids are the adults, and the fulvic acids are the babies, and the human are the diseased ancestors. So this gives us a understanding that among all of them, the humic acid and fulvic acid are the two most important active components which need to be there in the soil. So that is what the Actosol product we make. It's primarily made up of humic acid and fulvic acid. And that's what then allows us to replenish the soil and make it a fertile very fast. Next slide, please. So now, what are the foods the plants need? They need carbon, hydrogen, and oxygen. These, we say you get it free. Essentially, these are, plants derive it from the air, except now the carbon is getting deficient. And then the other food items or nutrients, we divide them into macro, secondary, and micro. The macro are the most commonly used, called NPK, or nitrogen, phosphorus, potassium. And then the secondary are calcium, magnesium, sulfur. And the micronutrients are generally boron, copper, iron, manganese, molybdenum, zinc, chloride, and cobalt. So they're like vitamins, we human beings take. Same way the plants need, these vitamins. So all these plants need these elements in a different combination, in different ratios or different amounts. And so that's where we are then have built up these whole industries to provide these fertilizer chemicals, we call them. Next slide, please. So the government of India has been subsidizing this increasing use of fertilizer because cost of making these fertilizers are high than the farmers can afford. So for example, I found that in the recent budget, which just passed this month, about almost $100 million have been allocated by the government to subsidize the production of the fertilizer. And among the most subsidized fertilizers are diammonium phosphate, which are, I've given here numbers as, 10,231 rupees per metric ton. And then the selling price is 24,000 to the farmer. Similarly, the MOP is muriate of potash, which is a natural potassium chloride, mineral which is mined from the earth and is then used as a fertilizer. And then there is a compound fertilizer, NPK. So this contains a nitrogen, phosphorus, and potash. Now, urea, which is made from the nitrogen which is extracted from the air, is also very costly. So government has fixed its price. And Professor Moni mentioned about urea being coated with the neem, which is again for government to stop the other industries taking the government benefit. They have mandated that all the urea for agriculture use should be coated with the neem. There is some question, it's questionable whether that's really actually helping, or rather neem is known to actually kill the microbes, and the microbes are very desirable and useful in the soil. So we're fixing one problem and then creating another problem. There are better ways to do this. So I'll share that with you. Next slide, please. So now let me give you a understanding about the level of the soil organic matter. This is based on farmlands in Halifax County. We call them, like you call different areas, the districts. In USA, we call them counties. And this is in Virginia. And now the most common method for analyzing the soil organic matter has been in use is called loss in ignition, where basically you take a soil sample, you dry it, and then you burn it in a furnace, and you weigh it before and after. And then assuming that during the burning you have burned out the carbon or organic matter, and then you can calculate the organic matter based on that. It's called loss in ignition method. Another method is a chemical extraction. But both of these methods are fundamentally flawed. They do not give a correct analysis of the humic matter or humic acid in the soil, which is more important than just organic matter. So here I have shown organic matter analyzed by loss in ignition method, organic matter analyzed by the chemical extraction method, and the last column is the organic matter analyzed by humic acid extraction method. And what you will see is that in the last column, in most of the soils, the numbers are almost 0 to a very, very small amount. And for a good fertile soils, you need to have the humic acid organic matter content somewhere in the 5 to 8%. And Professor Moni mentioned that in the current budget, they have allocated a huge amount of money to build these soil health labs or mobile labs. And if anything, I would like to help them, and we will be happy to provide them all the guidance that instead of using these flawed methods of loss and ignition, that they should consider using a humic acid extraction method analysis, which will then give a more accurate understanding of the soil health. And in fact, I have supported In this country, universities, Northeastern University, Professor Jeff Davis and his team, about in the last 6-8 years, took on to go and get the soil samples from about 600 different counties or districts in the U.S. farmlands, and have analyzed for humic and fulvic acid, and they are published. And their also data shows that the soils also are heavily depleted in humic and fulvic acid components, and that data is published in the. And if any one of you interested, you can look up on the Northeastern University Humic Acid group. Just do a Google on it and you'll find a lot of this. And there were about 15 to 20 undergraduate students were involved in that program. So that's one of the program I encourage the university to take up and support it for a long time. And next slide, please. So what is humic acid? Humic acid is a natural, organic molecule. It's a carbon-rich, highly functionalized organic molecule. It has a carboxylic, phenolic, carbohydrates, and enolic groups, and it's a colloidal organic matter. And it's one of the only organic chemical which is soluble in water at a pH above 2. And below it becomes insoluble or protonates, and it's brownish black color. In fact, when you drink tea, essentially you're drinking humic acid. And you can, next time you have a tea, ask for a black tea without milk and look at its color, and then take a lemon and squeeze lemon into it and let it sit, and you will see that the color of the tea will decrease, and at the bottom of the cup you will see a brown specks. So essentially what you've done is that by adding lemon or acid into the tea, you have lowered its pH, and the humic molecule in that have settled down. And why we are drinking tea, not only because of the caffeine and the aromatics, also, but it has a lot of antioxidants, and same thing is in the coffee. So the humic, this molecule is virtually present in all our plant kingdom. And go to the next slide. So here is the structure, this is one of the still nobody yet has solved a structure, except there are some hypothetical models. And these are two different models. The one going back into the 1970s is a model which shows that it has an aromatic core, and then it has these functional groups. But in the recent years, the scientists have proven that this molecule is actually a very well-defined molecule. It has 4 aromatic cores, and then it's held by these peptide bonds. And it's almost like a helical molecule, and with all these functional groups on it, or you can almost think of it as a human body. Our human body is a functional because of our these arms, legs, and other organs we have. Same way, this humic molecule has these unique functional groups on it, which allows it to take nutrients from the soil, or take it when we apply them in a form of fertilizer, and give it to the plant. It has ability to hold moisture, and so in fact it's a helical molecule. And I believe that this may turn out to be the building blocks of the plant kingdom. And this still needs to be proven, but this is and the other thing I found, as I have traveled pretty much all over the world, and I've taken soil samples from many, many places, and I found that you may have mineral components in the soil will be different depending on the underlying bedrock, but the organic matter is same. all over on this planet in the soils. So this is a unique to our planet. It's a fundamental to maintaining the viability of this planet as well as our own viability. Next slide, please. And it's a fourth largest storehouse of the carbon. Here is a Professor Moni also alluded to this very useful information, that when we look at where is the carbon distributed in our planet, the largest amount of carbon is in form of the sedimentary rocks, and which are almost to 2 million hectograms of the carbon. The next largest storehouse of the carbon are fossil fuels, which is in form of coal, oil, and gas. And third are our oceans. The fourth are our soils, and which are in form of humic substances. The fifth is the air. Now I'll digress here a little and share with you that what is the challenge we are facing and how actually our soils can be a solution to that. As you well know, that there's a huge concern building up on the climate change. And so what we are doing is we are pulling out the fossil fuels in the form of coal, oil, and gas and burning it. And then we are increasing it into the atmosphere, which is then causing us the global warming concern. And on the soil, we're stripping it off and sending it into the oceans. So this is a quite a telling information, which is telling us what we are doing, and we cannot continue to do this thing. It's going to be a huge challenge to, for a long time to come. Next slide, please. So now let's come to Actosol. Actosol, as I mentioned, is a humic and fulvic acid fertilizer. Again, which increases crop yields, for crops, vegetable, fruits. Anytime you grow plant, it helps. It produces superior turf, deeper roots, enhances uptake of fertilizer, replenishes depleted soils, and it promotes ecological balance. So those are the main points, but I'll share with you how it does it. So let's come back to who we are. As Professor Moni mentioned, that ARCTECH is a company I founded about 30 years ago. Go back to the slide. So we are based here in near Washington, D.C. And I was looking at that I'm here sitting in the middle of night time. It's about almost 1 o'clock here in the morning. And I looked at what's the distance from here to Meerut, and I found it's about 12,000 kilometers. And then Samir, who works with me on our projects in India, is almost 13,000 kilometers from here. And here we are the beneficiary of this wonderful technology to be able to communicate with each other. So ARCTECH company I founded after failing about 5-6 times in my efforts to help solve the energy problem by utilizing coal. And going back to my geology background, that led me to start looking at energy issue, and that led me to coal. And so as we were developing technologies, but we failed, and the oil prices came down. And so that led me to then look at a biotechnology approach to utilize coal. And to do that, I founded this company and engaged many scientists from many different disciplines and started developing this technology approach, which led us to develop these humic products as a byproduct of the energy production from coal. So essentially what we have now is we have a way to take coal and utilize the microbes to digest to produce gas, and then any coal which is left undigested, we convert that into humic acid products. So Actosol is one of those. We have multiple other products I'll share with you. So we've been developing and deploying, and so we have built a next slide, please. Yeah, so we have a prototype coal biorefinery operating here in Virginia, not too far from here, where we produce these products. Actosol is one of those products. We produce also a product called Humic, which is for water treatment. We produce another product, ActoHax, which is a product which is being used for dealing with a variety of waste materials, and we have deployed its application for converting bombs and explosives into fertilizer for the US military and some of the militaries in other countries. Next slide, please. So in the among Actosol, we make a multiple formulations or different products. The most common one which is used is a bioactivated agroactosol. And also we add NPKs, which is a turf booster. So it's an Actosol which contains 20% nitrogen, 5% phosphorus, and 5% potash. Horticulture, 10-10-10. And microchelated Actosol, which contains iron, zinc, copper, or manganese, and a calcium Actosol. So these are all water-soluble liquid products. So they can be applied in the soil, or they can be a foliar application. We also make another product called Nutrient Enhancer. And this is a product which is designed for coating the granular fertilizer, because farmers in India still are using a large amount of this granular fertilizer, which are manufactured there, NPK. So this product can be used for coating those products. And I'll show you that by using this product, you can actually increase their efficiency or uptake and decrease their use and lower the cost to the farmer. Next slide, please. So the humic acid advantage is that it's enhancing the yield. It's producing a healthy, deeper root mass, and it creates vegetation even in saline and poor soils. I'll give you some example on the saline, but I'll explain to you right now that why salinity is adversely impacts the soils and growing crops in it. The whole key to growing crops is that you need to have a water available for the plants to uptake water as they are growing. And the movement of the water is controlled by osmotic pressure. And the plants have a capillary system through which they take up nutrients as well as water. And I give an example that by comparing it with our human body, like our human body, we have two fluids, the saline solution and a plasma as if in form of a blood. And these two solutions or liquids, they move throughout our body, but they never meet at any place. And this is all control of movement of these through osmotic pressure. So osmotic pressure also plays a role in the plant uptakes of the nutrients and the water. So the osmotic pressure teaches that when there is a high and a low concentration of salt solution, it moves from the low concentration to the higher. So when there is a high saline solution or high salt in the soil or in the irrigation water, instead of that water going into the plant, the low salt solution water comes out of the plant to the soil, and the plant desiccates. So that's why one of the evidence you see in areas where there's a high amount of salinity that the plants have desiccated. If any one of you go on to the beaches, you'll see that because of the high saline water or high salt water coming up onto the beaches, not only the vegetation is scanty there, but also it becomes desiccated. The humic molecule has an ability to alter that osmotic pressure and allow the water to go from a high concentration to the low concentration. Another adverse impact salinity does, it when you have a salt, the sodium, it exchanges with the clays, and the sodium clays are very, very fine grained. So it makes then the soils very compact. And wherever there is high salinity, you'll see that the soil has a sort of a hexagonal, octagonal cracks, and that's because of that the sodium in this water has led to forming the sodium-based clays, which have then become compacted. So adding again humic acid, Actosol to those soils, you can very quickly make them open up or increase their tilth or increase their the permeability, so that you can then grow crops on those soils. Next slide, please. So Actosol has been approved from many US government regulations now in other countries as well as. But one of the most important approval it has is from the US Department of Agriculture for growing organic foods. Another approval it has is from US Environmental Protection Agency. This is one of the only product which is approved by the US Environmental Protection Agency for combining it with the pesticide chemicals. As we mentioned in our earlier presentation, that the plants are becoming, because of decrease in the soil health, plants are becoming more unhealthier. So they need more these plant protection chemicals, and that's leading to a high cost. And so this product, Actosol, can be combined with those chemicals to improve their efficiency, decrease their use, and makes the plants healthy. So this is a approval we have from the US government to be able to allow us to do that, because many of these plant protection chemicals are highly regulated because they're very toxic and they have to be applied in a right way. At the same time, the residue has to be properly tested to make sure that the residues are not left in the fruit, vegetables, and crops, which can then go into the humans and cause serious health issues to the humans. We have approval from the Organic Materials Review Institute, which also is equivalent to the US, the Government of India's new program, which they have instituted for organic food production. Again, we have approval from here, one of the states, South Carolina, from the Department of Transportation. They require their contractors to use it for applying it onto the highway areas to reduce the erosion, because this product helps to make roots very deep, and then the vegetation which is established on the banks of the highways stays stronger, as well as it sustains it. Next slide, please. So how does Actosol humic acid create benefits? As I mentioned, that it's a multi-dimensional chemical with the functional groups on it. So it has many attributes. It does biological benefits, it does chemical benefits, it does physical benefits. And there is a reason I have written them in this order: first biological, chemical, and physical. Because when you apply Actosol, and even with the application of very small application of about even 2.5 gallons or 10 liters per acre, with small application, the first benefit you get is the biological benefits. So it helps to accelerate the plant cell division and promotes the growth. It stimulates the hormonal activity, stimulates the growth and proliferation of the soil microorganism, and adds the photosynthesis. So when you apply in a small amount, the first thing you see is the plant grows bigger, the roots are bigger. And then you see that the next benefit you see is the chemical benefit, where because of its ability to high cation exchange capacity and chelation, it allows to efficiently transfer the fertilizers we talked about, nitrogen, phosphorus, potash, micronutrients, secondary nutrients to the plants in a much more efficient way. And it also uniquely, it has this attribute to convert phosphorus. Phosphorus is a very important nutrients plant needs, so are the human beings. So this has ability to chelate and make into a soluble form, because otherwise phosphorus in the soil is essentially an insoluble. So it's not available to the plants. So using Actosol, it helps to increase the uptake of the phosphorus, which is already there in the soil. It improves the buffering capacity, it increases the water uptake in the high salinity of the soils, as I explained to you. As you cumulatively apply, then you see the physical benefits. The physical benefits are it increases moisture holding capacity, it increases the soil tilth, and infiltration of the compacted soils. So this is how, and again, there's a huge amount of research books have been written on it. I just showing an image of one of the book from American Soil Agronomy. And many universities all over the world, academics have been studying this, but still the application of these are not there as they should be, considering the need out there. Next slide, please. So I have interacted with many universities all over the world. In USA, I've just listed some, like Virginia Tech here in our state of Virginia, Nevada, University of Georgia, Montana State, University of California, University of Wyoming, Clemson University, University of Maryland. And of course, in Egypt, there's been a huge amount of, not only in real application, in the real farm application, but huge amount of academic research has been done in Egypt. If you just even do a Google on Actosol at Ensham University, you will see a large number of publications from there based on their research work on Actosol. In fact, I'm told that in the last 5-6 years, about 10 students have gotten their masters, and about 2 or 3 have received their PhDs based on their research work on Actosol. One of the unique, they have shown that Actosol's ability to overcome some of the soil pathogens in the nematodes, which is one of the severe pathogen which is in the soils, which is also causing a huge problem and then adversely affecting the plant health. So they have shown research on that, and it's also proving out in these countries. In China, at Southwest Agricultural University. In India, of course, one of the first research was done by Allahabad University, where they looked at the effect of the micronutrient Actosol on growing strawberries. And then in the recent years, the KVK in Baramati have done a extensive amount of research, which Samir will share with you. And then, of course, some of the universities in South Korea. So I'm very big believer in engaging the university academics and especially the students with us, so that they can get a first-hand experience, learn about this particular science, as well as the challenges and the issues it can overcome. Next slide, please. So here I'm just sharing with you some of the key data. I mentioned to you that Actosol has an ability to increase the uptake of the fertilizer, and we talked about NPK. So it has ability to bind NPK up to about somewhere 35 to 50%. Whereas when you look at the micronutrients, it has ability to bind them almost 100%. So what it means that when you combine Actosol with these fertilizer nutrients, the most which the plants need are the NPKs right away. And whereas they need a micronutrients in a very, very small quantity. So Actosol, in fact, becomes a proportional release fertilizer. So it gives the plants at what time initially what they need and gives it in the right proportions. Because I'm sure you hear in market out there, there's some claiming a slow release fertilizer where they coat, but the plants need a certain of these nutrients right away. They cannot wait for that to become available at later time. So the Actosol overcomes that issue and is a better delivery system to deliver these fertilizers. The next slide on the right shows that how Actosol improved the soil tilth. This is tilth is a term which is used in agriculture, that how compact is the soil. And you measure it by rod penetration, where there's a standard rod's length and the weight, and you push it into the soil to see how far it will penetrate. And then the more it can penetrate, the better tilth the soil has. So by adding Actosol into a highly compact soil, you can see that on the right of the graph that it has increased the tilth. Whereas if you just apply only water, that the tilth is very low. The graph at the bottom on the left shows that how by adding Actosol you increase the microbes in the soil, which is again is very important for the health of the soil. The graph on the right shows that how it's helping an increase in the water holding capacity. So here we have tested two different soils and shown that by adding Actosol, it increases the water holding capacity of those two soils. Next slide, please. Now, this is a important information I want to share with you, something which was done by Professor Mellis of University of California. And he is a expert in looking at the plant physiology, that what are the factors which affect the growth of plant. Now, in the science, when we look at growing any types of cells, whether they're plant cells or animal cells or human cells, we use a nutrient solution, which is called Hoagland solution. Hoagland was a scientist going back maybe in the late 1800s or early 1900s, had come up with a mixture of nutrients or foods which are most desirable for growing any type of cells. So he tested a particular Desalina, which is an algal cell, and it's a model for any testing for any plants. And so in the graph, you see the bottom with the triangle, this is the growth with the nutrient solution, Hoagland solution. But when you add Actosol to it, you can see that the big jump in the growth of the number of cells. And when you add additional magnesium, sulfur, calcium, and iron, which are micronutrients, you can see the growth is even higher. So this is a direct evidence that how the Actosol humic acid is helping in cell division. That's why we see that when it's applied, the roots are bigger. The plant, the top growth is much bigger, and then of course you see more flowers, and that's what leads to more tillers and into the more seeds and into the more results in more crops. So that is, I think, is the crux of the mode of action we have, been able to figure out that how it's doing it. Besides other factors, I shared with you the physical and the chemical factors which impact its attributes. Next slide, please. Here we're showing that how Actosol is helping in increasing the micronutrient uptake. In the previous graph, I showed you that how it binds it, but in this one, I'm showing that how it helps to increase the uptake. Now, for example, the control, here we have a mixture which contain only boron, magnesium, manganese, and zinc micronutrient as in a solution. And we are showing that how much of it was uptake into the plant tissues. In the middle is where we have now put this micronutrients in a water solution, and you can see an increase in growth. But in the third, on the right, here we have chelated with Actosol, and you can see the increase in the uptake. Now, what this is telling us that currently the many micronutrients which are applied are applied in a form of a powder. So when you apply that, you need a very large quantities of those, large volumes. The cost is high, and they are excessively applied. Plants take up very little, and rest of it actually adversely impacts the soil health because they are salts. So the rule of thumb is that when you apply micronutrients in a powder form, you need to apply about 10 pounds per acre. If you apply them in a solution with water, you can reduce them to 1/10, which is about 1 pound to an acre. But if you chelate with the Actosol, you need 1/10 of 1 pound, which means about 0.1 pound. So you can decrease your inputs substantially, increase the uptake into the plants. So that's what Actosol, provides as a way to reduce the cost, increase the uptake, and eliminate having to adversely impact the soil. Next slide, please. So now let's come back to what is the healthy soil? The healthy soil, does all these various 5 essential functions. One, it regulates water. That means that if there is a sufficient organic matter, humic matter, which has a water holding capacity, when it rains, it holds it. If it's not there, then all that rain comes, washes off, and in fact, it causes the floods. And number 2, this healthy soil is able to sustain plant and animal life. For healthy soils, not only you need a humic material and to provide these various benefits I shared with you, but there is a certain small animals which are present in the soil, snails and others, besides microorganisms such as mycorrhizae and many of these fungus and streptomycin, and these are all very beneficial microbes which are in the soil. So you need a good healthy soil to be able to sustain it. Number 3, that it should be able to filter out the potential pollutants and retain only the good stuff for the plants to uptake. 4th is a cycling nutrients. What that means is that we provide certain nutrients in form of fertilizer, and plants take up, but the remaining, they need to, the soil keeps it in reserve. So when you apply next time, then you can apply lesser of those nutrients. Or many times a farmer will use rotate the crop. So at one time, farmer may apply a crop which has a ability to take up nitrogen. For example, legumes or even soybean, when you plant that, it has ability to take nitrogen from the air. And then that nitrogen, some of it gets used and some of it is stored in the soil. And the next time farmer can apply, or he can plant maize, and the maize needs a lot of nitrogen. So now the soil has retained in that nitrogen which soybeans had captured, and now is making it available to the maize. So that's called cycling nutrients, and it's a very important attributes in the soil which need to be, and the supporting structure which relates to the tilth. So this is really are the 5 basic observable facts which a farmer can observe. And Professor Moni alluded to that Government of India is also promoting use of the soil card. So soil card is nothing but a physical certain observations a farmer can make to establish the condition or the health of the soil. But it needs to be properly scientifically explained and trained, so that farmer can look at the right attributes, observations, and then record them. And beside that, I believe the soil card in India includes also to be able to do certain laboratory analysis, and that may be the part of that program they are going. Professor Moni mentioned about establishing these mobile labs, and hopefully they can adopt the correct analytical method to get a right analysis of the organic matter or humic matter in the soils. Next slide, please. So now I'm going to just show you some examples from here in USA and Egypt, and then Samir will take up and he will share with you some of the results from India. So this is a farm not too far from here. One farmer farms 900 plus acres, and that's Mr. Robert Lawson standing there. And the person who's sitting there is from Maharashtra, and that is a Mr. Rajendra Pawar, who is a farmer himself and has been actively involved in helping the farmers in Maharashtra area. So he came out to US, and I took him to visit at this farm, and so Mr. Lawson showed him that how with the Actosol use, he had taken this land which had belonged to his great-grandfather, and had basically had become very infertile, lost soil health, erosion, and loss of topsoil. So in the last 5 to 7 years, and he has turned it around and has become a very, very productive farm. And he's cultivates wheat, soybean, corn, tobacco, and sorghum. Next slide, please. So here is some examples, from his farm that he shared with me, that his organic matter, from in 10 years have increased. The blue one is from before about close to less 1%, but after it has gone up to now 5% level. Next slide. This is his effect on the increase in the crop. This is in USA, we use a bushel as a unit, which is roughly about 50-60 pounds. And so, was without Actosol was producing about 50 bushels, but after using Actosol, he has doubled that to 100 bushels per acre. Next slide, please. And this is what he's showing is the nutrient reserve. So his nutrient reserve on average is about 150 pounds of nitrogen per acre. And then the other phosphorus, potassium, and other things, they range from 10 to 45%. So here his input costs are very, very low. By the way, he does not use any granular fertilizer. He only uses a water-soluble fertilizer along with Actosol at an application rate of about 2.5 gallon. So he is producing with a 1 kilogram use of the fertilizer, he's producing 60 kilogram of food. So remember, I shared with you that the experts in India are now reporting that in India, the average yield has gone down, which used to be about 25 kilograms per kilogram of fertilizer. It has gone down to 6. And here is a farm which is producing 60 kilograms per 1 kilogram of fertilizer use. Next slide, please. So again, he's been producing 100 bushels of soybean, with Actosol. Here's on the left is the control, or without Actosol, and on the right is the soybean, with Actosol. Next slide, please. This is an example for use of Actosol for growing tobacco. Here we're showing the roots. The control is on the right, and the humic acid or Actosol treated roots are on the left. And you can see the difference, and the secondary roots are substantially increased when you use Actosol on that particular. So again, Virginia is known for tobacco, and I'm sure you probably hear these brand names, Marlboro and all of these. The tobacco is grown in these areas. And next slide, please. This is on soybean. This is an example where Actosol is combined with a plant protection chemical, and a lot of these plant protection chemicals, they adversely impact the plant growth and decrease the yield. But when you combine with the Actosol, you actually not only increase the protection of the plant, but also you increase the yield. So on the right is the without Actosol, on the left is a with Actosol, an example for a soybean. Next slide, please. This is an example with the Roundup Ready. This is a Roundup is a chemical which is sold with the genetically modified seeds which are being promoted. Roundup is become a very, very controversial and a high cost, and it actually also it does help to overcome some of the disease issues, but still it adversely impact the plant growth. So when this Actosol is combined with the Roundup, it not only allows that you can reduce its application rate, which is a then lowers the cost, but also it overcomes its negative health, the stunting of the crops. So this is a number of farmers in this area use our Actosol in combination with the Roundup Ready, who are growing these these crops with the genetically modified seeds. Next slide, please. Here's another example with the Accent. Accent is another, the DuPont's post-emergence grass herbicide. In plant protection chemicals, there are a number of different chemicals are used as insecticide, which is neem is one of the well-known herbicide. So this is another very toxic chemical. And so Actosol helps to overcome its toxicity and still provide the benefit, to the farmer at a lower cost, at a lower application rate. Next slide, please. Here is a study done by a professor from Virginia Tech. What he's showing in this is quite astounding, that he combined Actosol with a triazole fungicide, which is a common plant protection chemical, which is used by when the farmers on many crops, as well as on turf application, golf courses, athletic fields, and other places. So in the middle is what he's showing here is that how it impacts on the root growth. So in the middle is the control without using Actosol. On the left is the one which has a Actosol, and you can see the increase in root growth. But on the right, where he has combined Actosol with this banner and at a half of its recommended application rate, the synergistic effect is humongous. You can see the root mass is just quite an astounding. And so this is another example that how Actosol is providing multiple benefits. Next slide, please. These are on its application for vegetables. Again, as I shared with you that any type of plant you grow, Actosol provides benefit, whether it's crops, vegetable, fruits, ornamentals, or anything. Next slide, please. Let's quickly go through the slides. Okay, so here coming back to the Lawson form, what I guess I was trying to determine as to what is the cost benefit to the farmer. So in case of corn, he has shown that he gets a 30 times value than the cost of Actosol. In case of tobacco, it's a 20 times. And in case of the impaired lands, he was able to rejuvenate them in 18 months compared to generally it takes 5 to 10 years. Now, my objective is to help the farmers to at least gain a 2 to 1, at least minimum, so that if a farmer spends 2 rupees, then with the increase in yield, that he gets at least 4 rupees back. And so, but again, in many of these farmers, depending on how well they're following up the program and what their other practices are, in this case, they're showing a substantial gain. Next slide, please. This is a farmer growing kidney beans in Minnesota, and here what he showed that again the photos of the kidney beans, with a grower standard or means control without Actosol, is on the top left, and the bottom are with Actosol. You can see first that the size of the kidney beans are substantially increased. And when we took those beans and analyzed what we see is that increase in the nitrogen content, which means that use of Actosol has increased the protein content of as well as other nutrients. And overall, he obtained about 26% increase in the total amount of the kidney beans. Next slide, please. These are many different examples of here in Virginia. Next slide, please. This is a Actosol used in China. And this is in China, they have really done a remarkable job in they used to have only a 0.6 acre, which was allowed during communism time. Now I've been there many times, and they have really built up their agriculture and have substantially increased their food production. And a lot of it, and a lot of China is in the colder climate, so they build these low-cost plastic houses, and they grow crops in those. Next slide, please. Here is another farm in China. Next slide, please. Yeah, this is a from Egypt on rice. On the left is the untreated, on the right is the treated. So you see almost in Egypt, as you know, that all that fertile land they had, they have now built this metropolis. And the farmers are out there in the desert lands, which the soil is almost like, very sandy. You can see that there's hardly any organic matter in there. But they have found a lot of water. So they are pumping huge amount of water from the groundwater. And of course, the groundwater is now increasing, has an increased amount of the salinity. But in this case, with the Actosol use, they were able to double the yield of the rice. Next slide. This is the mangoes. Professor Moni mentioned they call it a Hindi fruit. In fact, I haven't had Indian mangoes for almost 50 years. But every time I go to Egypt, I happen to be there during season. And they always give me these mangoes, and they're absolutely delicious. And the reason they call them Hindi fruit, because mangoes were not native to Egypt or Middle East. They brought these mango cultivars from India. And so mangoes are now a very, very favored fruit in many of these countries. And so what they have shown that the top one is untreated. What they have shown is the best benefit you get on mangoes is by a combination of soil and foliar application, which is on the right. Next slide, please. This is on pears. On the right is the untreated or control, and on the left is the treated. Next slide, please. This is on peaches, because in Egypt, in this particular farm, they are really focused on growing, high value fruit crops. So go to the next slide, please. Yeah, this is for the strawberries, again in Egypt. On the left is the control, and on the right is the treated. Next slide, please. So here is a sort of a compilation of the data from Egypt for the last about 10 years or so on different crops. So, again on wheat, rice, sugarcane, potatoes, cucumber, pears, orange, grapes, apple, and mangoes. And, these are in different areas. Some are in valley, where it's a little bit fertile. Then the other areas are complete desert. So here they're showing that what is the increase in the yield. And so here they're showing an average increase from about 10 to 20%. And in the next column, they're showing that what is their in the cost of the chemicals, and they are reducing the amount of chemical used by 25 to 50%. And from that, they are lowering the cost of the purchase of the fertilizers. And then they're showing that what is the cost of the Actosol in relation to the additional value they are generating. So the number, if you will do the numbers, it will come out to about 1 to 4 they're gaining. In one of the columns, they're showing the cost of organic manure, because Egypt and like many other countries, they went big time on not only using the manure, they were producing animal manures, they were producing in their country, but they were even importing. But that led to a huge, not only huge amount of high cost, but also led to a huge amount of diseases and further deterioration of so in many countries, they have actually now banned the use of the importing manure from other countries. So in this particular data compiled over 10 years, they have shown that the Actosol use is a much better, lower cost, provides much better benefits, increase in the yield than using manure. Next slide, please. So now this comes to India, and here I'll ask Samir, my colleague in India, to pick up and share with you, what we have done in the Maharashtra area and some other areas in India. So Samir, you want to pick up from here?
Professor Moni for putting me on this panel. So whatever results you have seen in US and in Egypt, so we just tried to replicate the same thing here in India using Actosol. And
Mr. Samir, just 1 minute. Let me introduce you to the audience. Just for 2 minutes. Okay. We are very thankful for the very insightful and very innovative address with a lot of examples and the need for applying Actosol solutions for the dying soil in India. So, and he has given a lot of examples with respect to the topic of the today, and very effectively. And now Mr. Samir, he's Actosol expert, will talk about it. Before he talks, I would like to introduce him to the audience. Mr. Samir Sachdeva has over 20 years of experience across industry and market. He is an engineer and an MBA by qualification. He has worked in domestic and international experts. As he rightly put it, that he is an innovator, activator for agriculture value chain, and as an independent agriculture consultant based at Pune. And he is considered as an Actosol expert, according to the published document available. So, Mr. Samir, over to you.
Thanks a lot in terms of inviting me to be a panelist here at Shobhit University. I am really grateful to Professor Moni and Dr. Walia for representing me on this webinar. So what I would do right now is I will share some of the results which are coming out, where we have done small trials at KVK Baramati with some farmers. And I will this is one of the reports. We have got number of reports like this. So whatever is happening at Baramati is that whenever we have used Actosol, the soil organic carbon tends to go up. Salinity in soil, where it reflects on sodium, it goes down. And the yield percentage in the root zone basically improves. So that what Dr. Walia said, that capturing of carbon dioxide from the atmosphere and putting back into the soil. So that is the exercise which we are doing here. So I will share you with a lot of pictures in terms of what all we have done out here. So first slide is effect on sugarcane, because Baramati is a big area where sugarcane is in anyways grown here. So you could see on the left hand side where we have used Actosol in terms of seedling of sugarcane. It has got more root mass compared to the untreated one. Similarly, sugarcane crop, where it is planted after treated, then the height of basically a sugarcane plant was much higher by about 2 feet compared to the untreated one. The other advantage which we have seen in terms of pomegranate, which is again a big particular crop out in this geography, is that there is a lot of fruit drop, because drop on pomegranate. The flowers tend to drop, and the reason being some disease being there. So wherever we have used basically Actosol as a foliar, as by way of drip bilaterals, the drop rate on pomegranate has gone down. The size of pomegranate has gone up by about 20 to 25%. And the other thing which is outstanding by use of Actosol is that the color and the seed quality of a pomegranate aerial inside tends to taste better compared to a non-treated one. Same thing what we have seen in terms of grapes. So grapes has a problem of berry drop. So the stems and the grapes are not typically attached with each other, and when we shake these bunches they tend to drop, and any grape which has come off or fallen off from the vine tends to lose its shelf life. So what we have seen is that when we have sprayed Actosol and put it through drip, these farms, the size of the grapes is higher, bricks are higher, and the berry drop percentage is much low. Again, the experiment which we have done here in Sholapur on banana is that the growth on banana using Actosol what at least 30 to 35 days earlier compared to the untreated one. So these are the shared the pictures on this. So the growth itself on a banana tree was much faster and the plant was very healthy. This is on a guava which we are trying now. So even the Actosol treated guava plant have started to fruit earlier compared to the untreated one. These are just of the pictures of the vegetables which we have tried. So the main advantage is the size of the leaf increases. What I have also observed personally, the size of the leaf on vegetables increasing, but the thickness also increases. So once the thickness of a leaf increases, the chances of attack of pest on that particular plant reduces. So that is the first slide which Dr. Walia had said. It initiates plant cell division, wherein most of the chemicals which we use in terms of nitrogen and others, they increases the cell elongation. So when you elongate a certain thing, then the thickness goes down, and the chances of disease and pest coming on a product wherein we have used urea or excess of nitrogen, the pest and the disease attack is much higher, which leads to farmer buying expensive pesticides and spraying onto the crop. So that increases the cost of farming for a farmer. But wherein if we use something to amend the soil structure like Actosol, then we are also doing something which is good for the farming community, wherein the usage of pesticide will go and decrease. So apart from reduction in fertilizer, we will also have an impact on reduction of pesticides, which is more expensive than fertilizers which we are using right now. And that is also not healthy for us humans to consume. So this is again a picture in terms of tomatoes. So what we have seen, the attack of nematodes on tomatoes in chili or dieback is much less when we treat the soil with Actosol. So we have got more number of friendly microbes which tend to overpower nematode, and the results of dieback on these particular plants is restricted. So summary of the finding is that it has shown about 8 to 12% improvement in the height, stem girth, diameter, and other parameters. So what we do is that when we treat a particular plant with Actosol, we continue to measure the root zone, because root is something which is very, very important. So what we have observed is that the number of root and the secondary roots are much higher wherever we have treated the plants with Actosol compared to untreated ones. Other thing which we have noticed is that the pH of the soil has tended to go down. It is coming more towards neutral, because most of the pH in soils in this pocket is roughly about 8.2, which is not very healthy for any crop. So they tend to decrease. Perhaps say 8.2 has become say 7.6 in a period of 6 to 8 months. And organic carbon percentages have started to increase. Not massively, but a change of 0.2 to 0.3, which is coming in a yearly basis. And most of the farmers who have used Actosol, they come back and say that their soil has started to smell nice. That is again coming from microorganisms which have built up into the soil because of organic carbon being present in Actosol. And organic carbon is nothing but food for these friendly microbes which we require in the soil. And whatever results we have seen, there are only positive results coming out. We have not seen any negative impact of this product being used on the farming community. And more number of farmers now are interested in using and trying to help improve the soil structure so that they get a better yield, the cost of production on the crop goes down, and they are able to give a good quality food at a less cost at the farming level. Dr. Walia, this is another thing, nutrient enhancer. Would you like to take it forward and explain what it does? So this is another product. Apart from Actosol, we have also got a nutrient enhancer. So what we have seen or observed, how do we add organic carbon back into the soil? So the thing is, to add organic carbon into the soil, we have one product called Actosol, but it is in a liquid format. And how do we add a liquid product where India 60-70% is on flood irrigation? So it becomes difficult. With drip irrigation, it is much simpler. So then we came up with an idea that fertilizer is something which is anyway required by a farmer to put it on the ground. So when he is putting fertilizer granule form into the ground, can we have a product which is rich in humic substance, and we can coat the fertilizer granules with it and then put it into the soil? So there will not be any increase in one more operation for a farmer, and all he needs to do is that urea, DAP, or whatever he wants to use as a fertilizer, he can just empty 1 liter of a bottle in say 50 kgs of bag, mix it, and then just spread it on the ground. So by this method also we can ensure that the humic substance is going back into the soil at the desired levels. So you could see some examples of nutrient enhancer on the left, on the picture down below. So wherever nutrient enhancer has been used with a fertilizer, the effect on a plant is much better. So it is one more application by which we can coat fertilizers, seeds, and then put humic substances back into the soil which is required. So it has also improved the uptake of N, P, and K wherever nutrient enhancer has been applied during the fertilizer, then micronutrients, secondary, and others. So there is an improvement on the fertilizer usage on a particular crop when we have applied or coated fertilizers or seed with nutrient enhancer. So I think thanks a lot for this opportunity. So I've just shared few of these slides which we had, and these trials are underway any which way, and we'll continue to do that. Thanks a lot, Professor Moni. Over to you.
Thank you very much. You can come out of the slide. No, we can go to the main screen. Okay, good. So thank you very much for your very important lecture to the participants of this webinar today. And it is an Actosol and a nutrient enhancer with a lot of examples to give confidence to the farmers and the other farming, who are involved in cultivation. And you are given international, experiences and with the results and with the scientific publications that how applying the Actosol on various crops in various soil conditions, it will improve productivity. So as per the theme of the talk today, you see you have amply given example that how it increases yield, increases quality, and also improve soil health and increase income. And it is a very important webinar today, the talk by Dr. Dhaman Walia. I think it is about 2 o'clock, 2 a.m. in Virginia. And thank you very much, Dr. Dhaman Walia, for your very important address today. And it has generated a lot of interest with respect to what we would like to undertake at the grassroots level. And once I thank also that Mr. Samir, Sachdeva, for giving examples from India, and without any biasness. It is he reported what is available, what is seen from the grassroots level. The main takeaway is that today the farming community are doing cultivation on a dying soil. Now, how to save the soil, how to protect the soil. And as a geologist, now you have seen from the ground, below the ground, to see that how you can cultivate, you can help the farming community to increase their yield and quality and income, and how to protect the soil. And that is what is important. And you also given two slogan from Yajurveda, and how it is being, it has been talked about it, and over the period, how we are not, how we have gone away from the, directed, advice. And it is a very important, address. And I'm also very happy that you are following our webinar series very effectively, and you are reacting. And today your webinar is the way in which you have followed the 31st December 2020 Dr. Nadrajan's address, and how today you have, answered most of the, for the problems which have been observed through the solutions which you have, produced through your active scientific research for more than 35 years. And as a proud NRI, we are very happy to have your lecture through this webinar series from the Shobhit Institute of Engineering and Technology, deemed to be university. Our Honorable Chancellor has been watching your, address, from the behind the scene. Now he is on the scene. I would like to introduce the Honorable Chancellor to the audience, that Shri Kunwar Shekhar Vijendra is a co-founder and the Chancellor of Shobhit Institute of Engineering and Technology, deemed to be university, and also the Chancellor of Shobhit University, Gango. He is a prominent social entrepreneur based in New Delhi and carries leadership role in many organizations. He has been nominated as the co-chairman of National Council on Education of ASSOCHAM, the oldest apex chamber of commerce in India, for the year 2020-21 and 2021-22. Shri Kunwar Shekhar Vijendra is a persistent advocate of initiatives for education for all, secular values, crisis management through diplomatic and peaceful ways, and globalized system of learning and harmonious coexistence. He has been instrumental in the development of a number of higher educational institutions in North India, including 2 universities, many research centers, an Ayurveda Medical College, College of Naturopathy and Yogic Sciences, and a 100-bed Ayush hospital. Shri Kunwar Shekhar Vijendra is instrumental in establishing 4 centers of excellence: Center for Agricultural Informatics and E-Governance Research Studies, Center for Agribusiness and Disaster Management Studies, Center for Informatics Development Solutions and Application, and Center for Industry 4.0 Technology Studies and Application in the university to promote informatics and technology-led development in rural India. He is also planning to establish a Center for Health Informatics and Computing in the university. He is very actively involved with a number of social organizations. Acknowledging his contribution in the areas of education and other concerns, he has been copiously honored and awarded. He has traveled widely in India and abroad to the countries like USA, UK, Germany, Australia, Russia, China, South Korea, Vietnam, Mongolia, United Arabic Emirates, Mauritius, Rwanda, Uganda, and Croatia, etc., to participate in various professional, social, and educational activities. Shri Kunwar Shekhar Vijendra is a passionate Gandhian, avid reader, keen learner, social speaker, and occasional poet and a dreamer. And today, our Honorable Chancellor, Shri Kunwar Shekhar Vijendra ji, and today's talk has generated a lot of interest on, for the stakeholders, doing agricultural activities, farming activities in India, that Dr. Dhaman Walia has practically brought out through examples that how Indian farmers are doing their farming activities on a dying soil. How to protect the soil and how it can be done, the ways and means, and how he's doing work with the various universities in various countries, and in India also, he's working with the KVK Baramati and Allahabad University. And over to our Honorable Chancellor for his valedictory address.
Thank you very much, Professor Moni. I am indeed honored to have with us a very eminent speaker, Dr. Dhaman Walia. Thank you, Dr. Walia, for being with us today and for sparing the time in odd hours. I know Professor Moni many times insists that it should happen at the same time in India, and it is an odd hour over there, but it shows your commitment and conviction also. Conviction to bring a change in agriculture scenario, to add value. I was listening to your talk, and this dying soil of India is creating something wrong, and it is the biggest challenge today for human life, not only in India, in many countries, because agriculture and food security both are challenged. And when people like you, they found a solution and they decided, okay, fine, I will do something to add value to the agriculture. That is such a wonderful thing. My all compliments to you for the same. When you were discussing and you were talking about Actosol, so I was wondering that if you are using it in India or not. But thanks to Mr. Sachdeva, that my doubts that in India, if we are using it or not, they are cleared, and in many places in India it has been used. I believe that more and more it has to be used. I'm not an expert of the subject, but I am a very concerned citizen of this nation. As an academician, I wish that all those things which can add value not only to our agriculture, our farmers, but to knowledge also, we should discuss, we should deliberate, we should debate about. I am happy when you said that Allahabad University and KVK Baramati, you are working with them. But in a country like India, where we have more than 1,000 universities, where we have 45,000 plus higher education institutions, it means we have to do more. Because when you were talking, it was reminding me of 5 Eyes, what Honorable Prime Minister spoke about when he was talking about self-reliant India. And those 5 Eyes were intent, inclusion, investment, infrastructure, and innovation. If I look at these 5 Eyes, so in your product, in your company, in your vision, I can find everything. Only one thing what in India we may be missing, maybe infrastructure. And even infrastructure we can found because it does not need a rocket science to use all these products. Intent has to be developed. And that intent, yes, we will use it in our estates, in our farms, and it will change. That intent can only come when we talk about these products with our youth in the classrooms. Because generally what is happening in our agriculture universities, we are not talking about all these innovations. They look very simple. They look, okay, no, it was there earlier also. What is new in that? But new in that is when Dr. Walia says that my commitment is if you invest 2, I wish to add value to 4. And this is what exactly doubling farmers' income is all about. That we have to see that adding value, and we have to do that thing. So thank you very much. And I'm sure that with Shobhit University also, some synergy you will be able to find. Professor Moni, you can look into that. And what can be done that some micro certification if we can start initially. Because we are not a company who can add value in selling the product. But yes, we are a platform which can add a lot of value in creating awareness about the product, about the possibility through our agriculture students, through our other students, and we can see that how it will add value in the vision of Honorable Prime Minister to double the income of our farmers by 2022. So this can be one thing. And secondly, Professor Moni, we have to see that how we can do the advocacy of using it in states like Uttar Pradesh, a big state, or in other states, wherever it can be used. I was trying to find some more details. And I was looking at a research paper which was published in Nature Research in August 2019, and which was talking about that what is the use of these humic acid fertilizers in peanut farming and how it is increasing a lot. One more I was able to find when it was talking about that in Western Ghats of India, in coffee, how the quality was added using all these products. So a lot of things are there which can happen. In tomatoes, it is happening. And when Dr. Walia was talking about mango, so it was reminding me of our own mango orchards. And I was saying that, oh, there we can add value at least. So there is a possibility. So thank you very much today that you were able to be with us. You shared about this humic acid fertilizers, humic substances, about your product, and you gave a new vision that yes, with all these values, adding these values, we can bring a change. In India, you know, Dr. Walia, you said that from last 50 years, you have not tasted Indian mango. And those 50 years you must have missed, because now mangoes are still the same taste is there, but you must remember the last time you had. And we have to see that they are more tastier using what you are doing. And maybe then I will ask you, I will offer you, I will come to US and I will offer you, okay, look, now these are the more tastier mangoes, what you had, but they used what you are producing. So thank you very much, Professor Moni, for all these initiatives. I'm told that today it is your 20th webinar. Congratulations for that. It is your commitment which is bringing out this knowledge to the wider public, and people are knowing about it. And I am sure with Shobhit University and Dr. Walia, we will be in position to do something to add value to the lives of our farmers. Thank you very much. Namaste. You are on mute, Professor Moni.
Yeah, Dr. Walia, would you like to respond to the observations made by the Honorable Chancellor? Over to Dr. Walia.
Well, I want to thank him for taking his time to share his thoughts, and I've read a lot about him, and I'm very impressed that that he and his associates have taken this to build a university in a rural area. I was reading about it, and so to bring about a change in the rural area, that's what needs. And I'm, as a scientist, have always worked hard to get onto the ground, to put our solutions on the ground. And this Actosol is a part of it's a part of a much bigger solution which we are trying to help put out there. This is to address the climate change, address the pollution issues, address the waste issues. So we believe that in fact, by using Actosol in the soil, that will be one way to sequester carbon, because Actosol, the humic molecule in it has a carbon which stays in the soil. It does not degrade into carbon dioxide like many other organic materials do. So this is a part of a much bigger puzzle. We are trying to help solve. And we need all the help we can, your blessings. And certainly I will be communicating with you as well as with Professor Moni to see what channels we can open up to establish a collaboration. And I'm always very much interested in, working with the young. I'm more of a teacher, they say, than an entrepreneur, because I love to share what I have learned, and I learn a lot also from young people. So we hope that we can engage some of your young students, and to see how we can then get them involved, and they can then be the one who will then contribute, will make the changes out there.
Thank you very much. Dhaman Walia and Mr. Samir Sachdeva and the Honorable Chancellor for participating in this program and making the webinar very successful. And a lot of follow-up actions have to be taken, and it is given hope to work more vigorously with the farming community to the grassroots level. As I rightly said it, that this is a technology which can facilitate the 85% of the farming community who are small and marginal farmers, having their acreage less than having farmland operational holding less than 2 hectares. So thank you very much for participating, and I also thank all the participants who are participating from India and abroad. For further inquiries, please write, for more research inquiries, please contact Professor Moni Maraswamy, Professor Emeritus and Chairman, Center for Agricultural Informatics and E-Governance Research Studies, and Center for Agribusiness and Disaster Management Studies, and former Director General, National Informatics Center, Government of India, New Delhi. My email address is moni@sovietuniversity.ac.in. We thank you and have a nice day. We close the seminar. Thank you.